Do you want me to share my screen already, Carl?
Sorry, Hayley?
Do you want me to share my screen already?
No, I'd like people to see the group just
Sure.
for 2 seconds before we go over to your screen, and the chair will introduce you.
No problem.
Carl, you should be able to hide the videos that are non-active. There's a button
Everybody's
somewhere.
active. We're all here. It's just you, Peter.
Yes, I know.
Okay, Cynthia's back.
All right.
Sorry,
okay.
I had some network issues, but I'm back.
Okay, we are live on YouTube, and I'm going to hand over to the Fast Group 3 chair today, and that's Cynthia. Cynthia, you can take it away.
Welcome everybody today to our key lecture. Today we have Dr. Hayley. We have Dr. Hayley speaking, sorry, not Prof. She was once a planeteer and a core lecturer, and then she went on to major in science, and she is one of the first female key speakers. She's actually now based in Germany, working for EUMETSAT. So if you would please welcome her today.
Thank you very much. Okay, try and share my screen.
If you would please welcome her today.
Thank you very much. Okay, can everybody see my screen?
Yes, we can.
Great.
Thank you, Hayley.
Okay.
Whenever you're ready, thanks for being with us today.
Very welcome. It's a pleasure to be here, and thank you for the introduction, Cynthia. So as she said, I'm Hayley. I'm going to talk today about my favorite topic. It's the topic I've been working in for the last, gosh, it's nearly 10 years now. Both been, well, longer if we count the marine environment, but for the last 10 years, I've specifically been working on what we call marine Earth observation, and I'll tell you exactly what that means during my talk. Those are my contact details there, and let's get started. So to tell you a little bit more about myself and how I got here first, I think this will set the scene for a bit more about like what marine Earth observation is and how you kind of end up in it. I hope this is interesting for you. I had this motivation when I was a young girl. That's me in the rather unflattering school picture, top left. I had this idea that I wanted to do something that was useful to help people and the planet when I was young, and this has always driven me down a kind of environmental pathway. So I have a background in environmental sciences at bachelor's level, and at that point I decided that, well, the planet's made up of lots of complex systems. The ocean is the biggest one, so I'm going to focus on that. So that's where the marine part of the marine Earth observation title of this talk comes from for me. So I did a master's in oceanography, and it was during this time that I was first introduced to the idea of observing the ocean from space using satellite data. And that's really the second part of what marine Earth observation is. So I started using satellites, and I wanted to get more into this topic. So I decided to do a PhD specifically looking at the use of remote sensing, or satellite data, as it's also known. And I moved to South Africa, which is how I ended up being connected to all of you and the Access Habitable Planet, I guess, team, world, group. I started at UCT in 2010 and was involved in one of the courses in my first year, and in subsequent ones ever since, on and off, as I've moved around the world. So I very much enjoyed my 5 years in South Africa and was studying the beautiful oceans there from space, as you can see in those photos. After that, I slightly unfortunately, I guess, had to move back to the UK, where I've worked for 5 years in research as a marine Earth observation scientist, looking at various different ways we can develop satellite data to tell us different things about the marine environment, all sorts of different applications. I'll talk more about those applications in the bulk of this talk, but really I can't impress enough just how much we can actually do with satellite data to understand our oceans and the rest of our planet, of course, as well, but the oceans are my particular favorite bit. So during that time, I started working more and more on these big European programs, which is where I now work. So about a year ago, I moved to an organization called EUMETSAT, which is a very long acronym. So we refer to it generally as EUMETSAT or EUMETSAT if you're in Germany and you pronounce it that way. We are the European organization for the exploitation of meteorological satellites. And you might think, you said meteorology, what does that have to do with the ocean? So we primarily run meteorological satellites, but we also run ones for the ocean, and we study climate as well. So that's what I do now. So I work as a marine applications expert using our satellite data and helping other people to do the same. So that's how I ended up here. This is where I work, or where I usually work when I'm not at home, thanks to COVID. This office is just down the road. You can see the picture of it there. We're based in Darmstadt in the middle of Germany, so miles and miles away from the sea. But with satellites, you really don't need to be by the sea in order to study it. So this is one of the benefits of them. The organization's been around for over 30 years now, and we're an international organization. So effectively, when you're on site at EUMETSAT, you're not really in any country, although we are in Germany. We exist in this weird space of being an international organization like the UN or the World Meteorological Organization, those other sorts of organizations too. As such, we have member states, 30 of them all around Europe, and we have these two main mandates, as I said, providing weather and climate data to our member states, mostly to go in things like their weather forecasting services. And then we have additional responsibilities working predominantly with the European Union. So the thing that I'm involved with there, and you may have heard of it, is the Copernicus program, which is the world's biggest ever Earth observation program. It's focused around a fleet of satellites called the Sentinels, which we'll talk more about. And the idea of this program is to provide free and open data for the entire world, even though it's a European program, about our environment. And the benefit of this data is, or the program really is designed to try and help people to use this data to manage their environment better, for prosperity, for both planet and for people. So, really getting to the core of that aim I had as a little girl to try and help both people and planet to prosper. As much as we are based in Europe and we have mostly European member states, we also have huge international partnerships. And one of them in particular is with the African continent as a whole. So we work very closely with the different meteorological services and other institutions across Africa, including the African Union, on our different programs. So actually what you'll find is that a lot of the data that goes into the weather forecasts that you're receiving down in Cape Town or in Joburg is coming from our satellites. So we're very well connected to Africa, and I get the pleasure of working a lot with my previous colleagues from across the continent who I've worked with. So what is marine observation, Earth observation? I've given you a bit of a clue to this already. It's effectively looking at the marine environment using satellites. And this animation you can see now is just an example of one of the satellites that I work with. This is Sentinel-3. It's an optical, it's not an optical, it's a multi-sensor mission actually, including both optical and radar altimetry missions. So we have optical sensors that look at the color of the ocean, but also measure other ways that electromagnetic radiation leaves the ocean. This is predominantly used to look at temperature. And then we also have on board this satellite, as I said, an altimeter. All this does is basically pings little radar pulses down to the surface, and it picks up what the height is of the ocean. So we use this to look at things like sea level. This is just one of the fleet of Sentinels at the moment. There's we have 1, 2, and 3 up there. Each one has 2 twin satellites, an A and a B. We also have a Sentinel-5P. In the coming years, we'll have a Sentinel-4, another Sentinel-5, and later this year, hopefully, we will launch Sentinel-6. So there's a huge fleet of different satellites all looking at the Earth. They all have slightly different mission responsibilities, but the ones I'm primarily interested in are the ones with a marine responsibility. So that's Sentinel-3, the one you see here, and Sentinel-6, although my organization will also be operating Sentinel-4 and Sentinel-5 coming up soon. So it's a very exciting time to be working in this field. And this is the sort of data that you can get out of the satellites that we work with. So this is an image from Sentinel-3. It's from one of the optical sensors aboard the platform. This is from the ULCI instrument, the Ocean and Land Color Instrument. We call it ULCI. We love acronyms in this field. It's a bit of a minefield to learn them all, but we have a lot. As I said, ULCI measures effectively what we call the ocean color. And from this information, you can derive a lot about ocean biology, for example. And that's very clear in this example we've got here, which shows a cyanobacteria bloom. This is a certain type of algae that happened in the Baltic Sea last year after we had a massive heat wave in the summer in Europe. So this is one way we can look at the ocean using satellite data. We can also gather the data together and create long time series to help understand how our Earth is functioning over much longer time scales that are relevant for climate, for example. So we've had satellites flying for quite a long time. We've had Earth observation satellites flying for I guess between 20 and 40 years, depending on which specific variables or measurements you're interested in. This particular animation here shows, I think it's 10 or 20 years nearly of ocean color data. So this is the same data you saw before in the previous image. And this has been used to estimate the chlorophyll content of the ocean, which basically is an indicator of the basic level plant-like life, the phytoplankton that exists in our oceans. I think you guys have heard about these or will hear about these during your biogeochemical cycles lectures during the Habitable Planet course. So we can also gather this data, not just looking at snapshot images, but over long time periods to really understand how our Earth system is functioning as a whole. And I really like this perspective. It's one of the things that really draws me to the topic of Earth observation, is just how astounding things look from space, how incredibly complex the systems are, and how we can use this technology to really understand what's going on. So marine Earth observation has this very, very broad remit, if you like. We can use a range of different instruments to study lots and lots of different things. And this slide really just summarizes that diversity. In terms of altimetry or radar, synthetic aperture radar that you can see in the top left there. We typically are using this to get information about how our ocean is moving, whether sea level is rising, about currents and things like that. And that can be used in a whole range of different applications, from maritime safety, so ensuring that our ships don't end up like some of these ones on the left, either impacted by waves or by ice, for example. It can also be used to look at transport of different things. So whether, again, with ice, or how an oil spill is transported, or more recently, this is being used to look at how things like plastic pollution may be transported and affecting different areas of the ocean. So altimetry and SAR has this very physical kind of, it provides a lot of physical information about how our oceans work. Same with the sea surface temperature measurements. You can also use that information to understand the dynamics of how the ocean is moving. It becomes quite easy to see currents when you look at the temperature profile of our oceans. You can also look at inputs, for example, from rivers. Plumes from rivers are usually a very different temperature to the surrounding ocean, so we can pick that up. And temperature plays an important role in things like biological productivity, or in impacts on ecosystems, such as from coral bleaching. So sea surface temperature also has a very wide range of applications. And you can see from the image in the top left there that it also has, this is where our links between the meteorology world and the ocean world become even closer. So sea surface temperature and altimetry actually as well have long been variables. Although we use them in marine Earth observation to study our oceans, they've also been used in weather forecasting for a long time. These are really important variables to use to understand, for example, how hurricanes form, or any other kind of weather system you might be interested in. The bottom there is ocean color. So you've seen some examples of that data already, and this is my particular area of interest. My PhD was using this data to look at harmful algal bloom formation. This is a big deal in South Africa, particularly on the west coast, where it affects the aquaculture industry. But this is true across the world in different places. We get these blooms, and they can really impact the quality of our food and human health. Same with, we can understand some aspects about coastal water quality using ocean color as well. So whether it's safe for you to go swimming in a place, for example. And actually, one of the strengths of Earth observation really comes to fore when you use a lot of these different data sources together. So you can see in this figure here, they're in a kind of a Venn diagram. So you can cross over and use 2 or 3 different data sources together to have to open up a range of different applications. Things like marine spatial planning become you can do them more easily, more effectively, when you have an idea of both the physical environment and the biological environment. We also use this data in different ways for policy, so in environmental impact assessments, towards our understanding of climate, in our modeling for a disaster response, for example. And the data is also seeing an increased growth in use in things like the insurance and risk sectors, because this can help us understand the environments we're working in when we have marine infrastructure. So that's just a very quick whistle-stop tour across all the different applications that we can look at in the marine environment using Earth observation data. And we'll look a bit more specifically at some of these now. So in the rest of the slides that I've got here are just a whole load of really specific examples from recent years of work done by a whole range of people, and I've tried to credit them. You should see in the slides where the work was done. just showing really some of that capability. So top left there to start with, this is some images from a few days showing Tropical Storm Maria as it moved across the Atlantic. And with this sort of data, we can actually track the formation of these storms over longer time periods. This is really crucial information in terms of managing response. You know, we have to tell people to evacuate. It's ideal to know where things like a storm surge are going to hit so that we can plan and make sure that we minimize loss of life while also, you know, protecting livelihoods and infrastructure and allowing people to keep working where they can. You know, we don't want to try and not to shut down the economy too much when we don't have to. So this sort of data feeds into that kind of preparation. And that image, the images you're seeing there come from the SLSTR instrument, which is aboard Sentinel-3, the one that I mostly work with. On the right-hand side, top right, you've got an example of how altimeters have been used together. So all the different names that you see in the different colors on the left there are all different altimeters that are flown on many satellites. And altimetry is really, we call it, but it's a team sport. You have to have a lot of altimeters to really understand what's going on physically with the ocean. They make measurements in these little narrow along track bands as the satellite rotates around the Earth. And so using lots of them together, we can get a really full picture of what the ocean's doing over time. So you can see all those different satellite data records have been combined together in this one plot. And what it shows is what we know is happening from some of the other lectures that you'd have probably seen during your Habitable Planet workshop, that sea levels are rising. And altimeters are a really great way of us understanding how much sea level is rising, whether it's accelerating and how it's affecting different places. So altimeters are really crucial in our understanding and confirmation of that process. The bottom left is also looking at altimetry data. This is some work from somebody we worked with on a training course some years ago who was looking at validating a model. So they run a national service where they provide sea state information for people who are running ferries, who are running shipping services, etc. And so they have this model to predict what the sea state is going to be to advise them, you know, to manage their safety accordingly. And this model was validated with satellite data to see how it was doing. And what they were looking at in this particular example was the sea surface height, but they can also look at things like the waves as well from this data. The bottom right example, we're moving away a bit from weather in this instance and looking at, oh, sorry, go back again. We're looking at the atmosphere. So it's not just the ocean we can look at from satellites. Although when we are looking at the ocean from satellites, a lot of the time what we are seeing is the atmosphere, and we kind of have to correct for the effects of the atmosphere to actually get to the signal that's coming from the ocean. But in this example, you can see how the smoke from the fires in Australia last year was spreading across the ocean there. And we can, you know, look at both this and things like dust storms from an atmospheric perspective, but then we can also see what the corresponding effect is in the ocean by using the data together in synergy. So just like none of the data forms are really separable, you know, you want to use them together to get the most out of them. You also can use the data to look at different parts of the Earth system that affect each other as well. So the atmosphere and ocean are very intertwined in that sense. So the next set of examples here, these are carrying on with some weather examples actually, but just to give you a bit more information about how some of these different forms of data work. The example on the left is again another hurricane, as you saw in the previous example. This one was Hurricane Dorian. But here we've got, as well as the image that you see, which is from one of the optical sensors, which shows all the clouds and things like that. Overlaying, you've got information from the altimeter. So those dots that you see show both the sea surface height anomaly, which would be associated with, for example, a storm surge that comes ahead of a hurricane, as well as the significant wave height, which is waves that would be associated with this phenomenon as well. So using these data in combination can give us information about what's happening with these storms in real time. We try and get this data out as quickly as possible to different services around the world so they can use it, but also tell us about what the likely impacts are going to be from these different facets of these phenomena. Similarly, we can also look at what happens after. So on the right-hand side there, you've got two images. These are both optical measurements, just looking at the color. This is a Typhoon Hagibis, again last year in Japan. The top image you see is before, and then below is after the typhoon had passed through. And I'm hoping you can see there that there's a major difference looking at the blue ocean around the coast there, where before you know, the ocean looks, as you might expect, mostly blue. But after, if you look down near the coast, you can see huge amounts of sediments that are rushing out into the marine environment. And this gives you an idea of just how much flooding was going on land and then what's happened afterwards. Now, obviously, this can have a huge impact on marine ecosystems and various different activities, as well as the impact that it has on humans living on land. So we can use satellite data at different points in kind of events to understand what's happening. So we can also look at ocean ecosystems, as I've mentioned. The left image you've now seen several times, and it's my background. It's one of my very favorites from the last couple of years. So we can capture these different images of these blooms, which can sometimes have harmful effects. Cyanobacteria are one of them that can be impactful, particularly on human health. Same with aquaculture, as we'll learn later on. So we can capture that information purely. But we can also look at how the ocean works in terms of the physical and biological interactions. On the right-hand side, you've got two images taken from the same day. This is of the Mediterranean Sea, and you can see in the top the sea surface temperature, and then lower you can see the corresponding chlorophyll concentration. So you can see there how the differences in the sea surface temperature can be linked to the patterns that we see in biological productivity. And this really helps our understanding of these complex interactions between the physical and biological activities that go on in the oceans. This is a really interesting application by some of our colleagues in France, and what they've been doing is using the satellite data similar to the ocean color, as you saw in the previous images, to identify the presence of these large accumulations of a thing called sargassum. It's like a type of seaweed, a giant type of algae, and it grows in the middle of the ocean, and it can be transported across huge ocean basins. And when it comes near to the coast, you get the situation that you can see in the bottom left there. I think this one is in the Caribbean. Huge amounts of this sargassum wash up onto beaches. And I don't know about you, but that's probably not a beach I really want to go on holiday on. So managing this stuff is really difficult for hotels in these beautiful resorts, you know, that rely on their nice natural beaches to attract tourists. So what they can actually do is, if they know it's coming, they tend to put booms across the bays where the hotels are, for example, to stop the sargassum floating in. Or they can plan where they might need cleanup if it's going to land on beaches, etc. They're actually trying to use this stuff in different ways as fertilizer and things, so it doesn't go to waste. It's a natural phenomena, but it can be, yeah, quite bad for business if you're in the tourism sector in these nice places that normally have very nice beaches. So that's just one way satellite data can be used for monitoring that. We can also combine this with currents to try and estimate where it's going to go. Water quality is super important, as you might have guessed from all this talk about algae, and satellite data is seeing growing use around the world, in Europe and in other countries and continents as well, for different policy applications. So in Europe, we have this thing called the Marine Strategy Framework Directive, as well as the Water Framework Directive, and lots of other bits of relevant environmental policy too. And countries have to show that they're complying with this. And one of the evidence methods you can use now is satellite data. So you can use that to estimate what your coastal water quality is based upon different indicators that can be derived from the satellite, such as estimates of eutrophication or of turbidity and things like that, basically an idea of your water clarity. And this can help countries to both report on that and to see how their management activities are affecting what's going on in terms of their water quality. And obviously this data is free, it covers the whole area, so it's quite a relatively cheap and quick way to get a picture of what's going on in your marine environment. Aquaculture is a huge focus for us in marine Earth observation. This is my background, as I mentioned before. In the left is a really nice example from South Africa. So that's your west coast there in the top image, with Cape Town in the bottom of it. And the data is currently being used to detect the presence of these high biomass blooms or red tides along the west coast. And this is forming part of various government initiatives to protect and enhance the blue economy, to grow sectors like the aquaculture. You can see the abalone in the pictures there, or to understand, predict and manage impacts from these red tides, such as the example bottom left, which shows the rock lobster that have walked out from a red tide in St. Helena Bay area. So that's one way that the data is being used in South Africa. Similar work's being done in the US, where they have a lot of these big red tides as well, and across Europe. From the European perspective, on the right-hand side, you can see some other examples of using this data for the aquaculture industry. This is some stuff I worked on in my previous job. We were looking at the aquaculture industry around the southwest of the UK and in Scotland. And we were trying to use the data to characterize different types of blooms that were happening, because some are harmful, some are not. And obviously the ones are harmful that we want to worry about, the ones that aren't, ideally we don't. And knowing which one is which can affect your decision making, which ultimately affects the amount of money you can make from your business. So we were developing that sort of technique. We were working with both mussel farmers, salmon farmers, and lobster farmers to help them, respond in kind of real time to make better decisions for managing their stocks. The other thing we did with this data, because we started to accumulate quite a long time series, was to generate risk maps. And this was something that was really interesting for insurance companies, because they need this kind of information to calculate the risk that it is, or the risk that exists in a particular activity, so they can offer insurance at the right level to people. So they were quite interested in this for providing insurance services to the aquaculture industry. Further water quality applications, these are some other really good examples from around the world. So the left there is an app. You can get this on your phone. I have it on mine from our colleagues in the Environmental Protection Agency in the US. They're detecting cyanobacteria, the same as the ones that are in the picture behind me and the image you've seen a few times, because this has these human health impacts. And so they've been using this data to help their regional water quality management. And they've actually found that using this data has saved them quite a lot of money in terms of what they're doing in terms of monitoring and response to these different events that happen with cyanobacteria blooms. They've just published some interesting work on that. So you can actually download this app and have a look at it yourself if you like. It's quite interesting. The top right was some work that we started doing in my previous role, where we were looking at links between the ocean color and the turbidity in the water, so the water quality in different environments, and the presence of cholera, which obviously is a disease that's still hurting a lot of people globally. And we wanted to see if we could help map that, where hotspots were likely to be, again, to help deploy management most effectively, and different resources for management of these terrible diseases that still affect us. The bottom right, this was a really unusual example, actually. I've only seen this once, but it was very cool. This was in Canada, and they had this example of herring spawning, something that happens every year. It's a very natural thing the herring do when they breed. They spawn, they produce lots of eggs. And when you're stood on the coast, you can see that it discolors the water. It makes it this kind of milky white color. And you can actually pick that up from space. There's so many of them spawning that you can see it. So the two images you see in the bottom are from two different satellite sensors at different resolutions, showing these features of Vancouver. But what was really interesting about this event was that it was linked to an outbreak of cholera. Again, the same sort of the same diseases we were talking about just now, from people harvesting and consuming the eggs, which is something that the First Nations people in this area do routinely and have done for a long time as part of their heritage. But it's interesting that we could see the presence of this and perhaps start linking up these incidences with what was going on in the water itself. And there's lots of human activities that we can see and provide data for from space. So the example, the top left you see there, these are hotspots. So we can look at fires from space. So, these bushfires and things that have happened, we can often see those from space using the temperature sensors and the color sensors just to look at the land. We can see smoke, etc. But we can also pick up activities. So in the top left here, what you're seeing there is these persistent hotspots related to oil and gas activities. So actually just being able to map these resources and these activities is really useful information for planners. And we can see what the kind of behavior is of these industries over time using this information, which is really important for future management. Top right, similarly, again, temperature data. This was from one of the trainees from one of our courses, was looking at how the water temperature in different areas around the Gulf of Riga related to different bathing locations. And they really wanted to create this kind of smart coasts concept, where they were actually telling people, what the water temperature was likely to be in different places at different times. So they were bringing people closer to the information about their region environment, and being able then to communicate messages about climate change and such like. So you can use the data for that kind of thing. Various different startups are using this data now. One of the ideas with the program, particularly Copernicus and making the data free, is to allow this kind of innovation so people can create business ideas, make money, solve different needs. And various startups are now using data for different fishing and shipping related activities. In this regard, some of them you've already seen. One of the most unusual applications I've seen of the data so far, in the bottom right here, comes from a lady I met on a training course that we ran some years ago. And she's an underwater photographer, and she was actually interested in how to correct imagery. So, you know, all these beautiful films you see that get made, documentary series of the underwater world. One problem they have is that the light that reaches those depths is not the, it's not like when we're on the surface. You know, we don't get the full range of color underwater because water absorbs light at different wavelengths as well. So things tend to look this kind of washed out blue. If you've ever been scuba diving at depth, you'll have seen it. But when they film underwater, they kind of want to correct that. So you get an idea for what color things are really, you know, how beautiful coral looks in all its different colors and shades, etc. And so she was looking to see if she could use information from satellites to try and improve this process. And it turned out she could. So what she was using was an estimate of how that light absorption was happening, which varies across the world. So depending on what's in the water, the amount of light and different colors of it that are absorbed by different components in the water will vary. So you need to have kind of an adaptive method to correct your images. And so this was what she developed using this parameter that you see on the right here, which is basically a measure of the sort of transparency of the water and how light was penetrating with depth. And I just thought that was, I would never have thought to connect those dots, and I thought it was really amazing that she came up with something so innovative. And so I'm coming to my last couple of slides. I just kind of wanted to summarize a little bit about what my job looks like day to day. I mean, it's super diverse. As I say, I used to work more in research and developing the applications, but now I work in this really interesting role between the organizations that run the satellites and send out the data and the people downstream who are using them for different applications. So I do a lot of document development. I run a lot of training courses. I have to understand a lot about what's going on technically, but also spend a lot of time doing what I'm doing now, talking to people about the data, answering their questions, and taking the feedback they give back to my organization to say, we need to improve this. You know, maybe our next generation of satellites needs to be slightly different. You know, all these bits of feedback we get from our users are absolutely vital to driving this whole industry forward and innovating further in terms of what we can do in the future and what people need. And I work a lot with lots of different people from all over the world. So that's one really, really great thing about this. Satellite data tends to bring people together, I think, from all over the place, and we share satellites amongst countries and continents all the time. So it's a really nice kind of international effort, and it's nice to work in that kind of community. So if you'd like more information about this topic, or you'd like to start getting to use some of the data or learning about it, we offer various training opportunities. The website there, training.umetsat.int, has our courses listed on them. Most of them are online at the moment, of course, which is great because it means they're actually more open for people to take part in some ways. But we also run courses normally around the world with different partners. We've held a couple across the African continent, in Ghana, in Tanzania, in South Africa, and we work with regional partners really closely to deliver those. So whether you want to do something online or in person in the coming years, there's probably something there for you. To access a lot of the data that I've shown you today, the Sentinel-3 data, you can go to coder.umetsat.int. You can just register for an account. It's free, and you can browse through imagery and have a look and see what the data's like. You can download it and then start working with it. There's a lot more information about the satellite itself on our website there, and the same with the Copernicus program. If you want to see the whole picture and not just the ocean part, but also what goes on with the land and the atmosphere and the climate parts, there's a wealth of information on the copernicus.eu website. Similarly, if you really want to get hands-on with lots and lots of data, there's various different projects that are going on at the moment, but one that I'm closely involved in is the WECIO DIAS system, they call it. It's a data information and access service, which allows you to basically come to the data and use computing services right next to it. One of the biggest challenges we have in this sector now is having probably far too much data than we know what to do with, but that's good because I think it really helps us to get into these sort of devilish problems of the environment where you need a lot of data to understand what's happening. So check that out if big data is something that interests you. And I think with that, that's me. So I'm very open to questions. Thank you very much.
Thank you very much, Dr. Hayley, for the interesting talk. Very informative as well. Thank you so much for giving us your time. And I'm sure people have a lot of questions. So can we just give Dr. Hayley a round of applause first?
Thank you.
All right, thank you so much. So let's take questions. Who's got some questions? Let's see. Okay, Tamulo, do you have a question there?
Yeah.
Okay, you can go ahead and ask your question.
Okay, so let's say we have some water bodies around our areas, because I'm from a rural area, right? So let's say I want to learn more about these things so that I can help the people around my area into having more secure water, which is healthy and does not affect their health or their animals' health. Ne? So like, how long will it take for me to learn this thing if I register now?
Not very long. I mean, really, if you just need to get started looking at some images, you know, if that's enough to see, I mean, if you live in an area, for example, where these big blooms are a real problem, or things like water hyacinth are a real problem, you know, or it's very visible pollution that you're seeing, even just getting a quick look at an image might be enough. And there's a lot of services now, both on our website and in some others, where you can actually just see the imagery, you know, like the one that's presented behind me, shown as kind of like almost like a photograph. So you can get that pretty much straight away. If you want to get more in detail with the data and look a bit more at you know, what it's actually measuring, so to get an estimate, for example, of a chlorophyll concentration or a turbidity estimate, you can also do that pretty quickly. So we've got some, and I would recommend this is a good place to start. We have a couple of YouTube videos on our channel which show you how to download a data scene and some software that you can download and open it in, and how to explore that data. So we've tried as much as possible, though there's a lot of data and it's quite complicated, to make it quite easy for people to get started exploring it. And then, you know, if you've got questions about it, you can always send us an email, me personally, or our help desk, which is on our website there. And we're always happy to kind of help walk you through the process to get the information you need. I would also say there's a lot of really good local partners that we work with. So, I mean, in South Africa especially, there's quite a few organizations. The CSIR are involved a lot. There's a company called Cyano Lakes who do a lot on water quality, particularly in small water bodies. You might want to check out what's going on with their work and maybe collaborate with them as well, because they have a lot of regional expertise, which is excellent.
Okay, thank you very much.
You're welcome.
Thank you. Does anyone else have a question? Kuhle?
Thank you, speaker. Thank
You're
you. Earlier you mentioned something when you were presenting the impacts of the weather events. You mentioned you firstly showed us the pictures of the impact of typhoons. As a typhoon, I don't know, and
Typhoon,
then typhoons, and then the hurricane. So in my understanding, hurricanes is a strong wind. Is there a difference between hurricane and typhoon?
It's a really good question, and actually not really. So it's actually just a difference in nomenclature. Depends on where they are in the world. So when they're in like the Atlantic and they're affecting America, they tend to be called hurricanes. When they're in the Pacific and they tend to be affecting Asia, you hear them called typhoons. I think they have slightly different measurement scales that are used by the regional Met services, but effectively they're very similar circulations that are affecting it. So yeah.
All right.
Great
thank
question.
you. Dr. Hayley, I've also got a question for you. Can biomass burning increase and decrease surface and primary productivity?
You mean in the ocean?
Yes, in the ocean.
It's a really interesting question. I would say it probably depends a little bit on what the ocean you're looking at is doing and what it's like in terms of what's going on there. So the phytoplankton, the things you see in the green behind me, if they are limited in certain nutrients and then you put them in, say from inputs from from burning, if there's stuff in the smoke that falls and then deposits on the ocean, if they're nutrient limited in some way, then you could spur growth from this kind of thing. Same thing happens with dust. Dust is another one. You know, often parts of the ocean are iron limited. So dust often is a big source of iron into the ocean, and we can see that. We've had examples as well from volcanic eruptions, so different nutrients coming in from what's coming out of the smoke, the ash plumes and all that, that gets deposited in the ocean, and that can then also prompt the phytoplankton to grow. If they're already in an environment that's very nutrient rich, like the Benguela, for example, then probably you're not going to make much difference. They've already got as much food as they can eat. You know, they're kind of fat, like little things, very greedy, they're very spoiled. So you might not see much change there. But if they're in a nutrient limited environment, yeah, I think there's a possibility that these kind of activities can have an effect. From the biomass side, I guess it also depends, you know, how much is burned, how far that spreads, you know, whether it's enough of an impact to really be seen. But yeah, potentially a lot of what we do on the land really does affect the ocean. I mean, these systems are very interconnected. It's a great question.
All right, thank you. So Samke, you had a question? Samke, yeah.
Okay, what I would like to ask Dr. Hayley is that, does aquaculture cause water pollution? Are there unfavorable circumstances linked to water culture, to aquaculture?
Yeah, it's actually a really interesting point to raise, and it's not something I really showed there. Aquaculture is one of these things that can impact the environment and be impacted by the environment. So I've mostly focused on circumstances where we're looking at what the ocean can do to aquaculture, which in places like the Benguela, where you get these big harmful algal blooms, it's kind of the ocean that's the threat to the aquaculture. But in some cases, yes, the aquaculture itself can actually cause a lot of impacts on the environment. We looked at this a little bit in China, where they do a lot of seaweed farming. And in fact, they were finding that a lot of the seaweed was growing kind of then out of control, and it was ending up clogging up local beaches and things like that. Similarly, where you have a lot of very intense fish aquaculture, if you're putting in a lot of additional nutrients, which you usually have to feed the stocks, that can then also create a water quality issue. You know, if you're basically have a very high stocking density, whatever you're farming, whether it's fish or shrimp, prawns, whatever, you know, they eat all that food, or excess goes into the environment, or their waste products come out, that can also cause issues, make the kind of water more polluted or reduce the quality in general. So managing that is another thing that we can kind of use satellite data for, is to see what effect is that having. Like, are we seeing more increases in things like eutrophication, so that, you know, the excess plant growth as a result of excess nutrients around aquaculture farms? Those are the sorts of questions that we can answer using satellite data. Yeah. So yeah, it can be quite an impactful thing.
I think my internet's cutting. All right, thank you so much. Does anyone have any other questions? Does anyone have any questions? I see Zandile's got a hand up. Yes, Zandile, you may ask your question.
Thank you so much, Cynthia. Thank you so much, Dr. Hayley, for such a wonderful talk. It was very interesting, and as I am in the environmental management field, my question is, can the satellite pick up microplastics? Because plastic pollution is one of the greatest issues that we are facing. So that we captured.
Yeah, it's a really good question, and one a lot of people have been asking lately. So it depends a bit on what the plastic's doing. If it's in very small forms, they tend to drop out of the surface of the ocean quite quickly. And when things drop out of the surface of the ocean, it makes it difficult for us to see them physically with our satellite data. If they're accumulated in quite large amounts, then maybe we can pick them up. There's been some work that shows that with large accumulations, you can potentially monitor them from satellites. They have a very different optical signal to like the plankton you see behind us, right? So plankton, they have this very strong, or phytoplankton in particular, have this very strong interaction with the light environment because they absorb it as part of photosynthesis. So they have a very distinct and very clear optical signature that we can exploit. Plastics isn't quite the same. If it's in large accumulations, it scatters a lot. So yeah, you can distinguish it from other things that are going on in the marine environment if it's big enough to make that kind of impact. Another way that, and for me, this is kind of, I think, one of the most useful ways that we can use the satellites to look at plastics in the ocean is trying to predict where it goes when it enters the ocean. So we know where a lot of the plastic comes from, like we know it comes out of rivers, for example, from our human activities, and we can measure that quite readily on land. once we know where it goes in, we can then use the satellite data to kind of figure out where it's going and where it's likely to be dispersed to. And then that has a lot of, you know, we can then use that information to decide, like, is this an area at risk? And maybe you don't want to put your aquaculture farm in an area where you know microplastics are accumulating. It's probably doesn't make for the highest quality produce. So yeah, that combination of the using the physical data to kind of predict transport, I think is really quite something we can use a lot.
All right, thank you so much. Lutendo, you had a question, and then we'll go to Teresa after that.
All right. Can you hear me?
Yeah.
Okay. Thank you, Dr. Hayley, for a wonderful talk. I was watching through YouTube. I had to come back in here. So in South Africa, I think ever today, there has been an announcement that on Friday we'll be receiving cold front and a whole part of South Africa. So I saw you did cover it a bit. Actually, what is cold front? How does cold front form in the oceans, and how does that actually has to now move to us, and now we have to wear like jackets and etc. Can you just please touch a little bit on that?
I can try. Unfortunately, it would be. I really wish I was in the office, because I'd go and get one of my colleagues right now who's a weather expert to help talk to you about it. But yeah, I mean, especially in South Africa, I mean, your weather is very driven by what happens in the ocean, right? So these different ocean circulations combined with what's going on in the atmosphere will drive these different systems on towards land. And from like when somebody says, you know, we've got a cold front coming, you can often identify it and see it depending on where you are in the world. I mean, for South Africa, from my basic understanding of the weather systems, I'm definitely not an expert. You can see these things coming from quite a way away. I remember when I was living there, they seemed to come on like a weekly cycle, and it was always the weekends. You know, you'd finish work for the week, and Saturday this cold front would be there. And then, you know, next week, the same thing again on a Saturday. So you can see them a little way physically. You can identify the cloud types from the data and see what's coming. You can also, you know, force the data into models to predict when and where they're likely to come. And that's where things like the sea surface temperature can have quite a strong influence, as well as measurements of things like wind, which is another thing that satellites can do that we didn't touch on as well. So yeah, that gives you a little bit of information in about it. But if you want to find more, I can probably send you some good videos that some of my colleagues have done on more specific weather phenomena. It's a very interesting topic, but unfortunately not one I know a huge amount about.
All right, thank you. I hope your question has been answered rather thoroughly. Teresa, you can go next.
Hi, thank you, Doc, for your amazing presentation. It was really informative. Hi. Can you hear me?
Yes. Yep.
Okay, yeah. I was saying thank you for your amazing presentation. It was really informative. So I have a question. So I hear you talking about how satellite can be harmful or causing certain disasters, right? So my question would be based, it's like, can you have, do you or maybe know about advanced satellite which could be used to control the environment disasters, or maybe to protect the society? Yes. Thank you.
Yeah, so satellites in general, I mean, they're these mostly kind of passive things, right? They're just floating up there, mostly just taking pictures or making measurements and monitoring things. So, I mean, we use some active methods, like we use altimetry, but they don't actually impact us on Earth at all. Like, you know, you could be hit by an altimetry beam coming down right now and you wouldn't know. So, you know, they're just quietly kind of up there doing their business. So they can't really affect what's actually going on here, but they definitely can be used in terms of managing and like preparing for things or reacting to things. And I mean, the data that we're providing is very, it's open, it's free for everybody to use, but there's a huge history of satellite data being used obviously for military purposes and for things like that as well. So, I mean, we as the, general members of the public don't get to see that data, but really advanced satellites can look in very, small spaces. Those are mostly used, for, like I say, for military purposes. But more and more, we're seeing a lot of satellite tech like that being deployed specifically for things like disaster relief monitoring. With a high resolution satellite, you can answer questions like, are the roads open? Say you've had an earthquake, are the roads blocked by mudslides or anything like that? For a disaster response planning, which has to happen really quite quickly, satellite data can be incredibly valuable. And the data that we're providing freely and openly to the public now is still very, very useful. In that sense. I mean, the highest resolution provided by Copernicus is like 10 meters. So at 10 meter pixels, you can still see a lot about what's going on. You can still look at a lot of resources like that and figure out what we need to do to help protect people.
All right, thank you. Does anyone else have any questions? Dina?
Thank you, Chair, and thank you very much, Dr. Hayley, for this wonderful presentation. One of my questions has already been answered. I just feel like you guys are watching us all from the top and you see everything down here. So anyway, another part of my question is that since satellite data require a lot of things, like including pollution, invasives and stuff, do you guys also offer solutions to this? Let's say, for example, something has happened elsewhere and then someone is doing the same research, maybe in South Africa, which is very far. Do you guys have specialists that can help with solutions, or is just data from you guys?
So we offer expert advice. We don't tend to do research ourselves as an organization, but we tend to have a bit of a facilitating role. So, either somebody who thinks, oh, I'd like to use satellite data for this application can come and work with me during, say, like an internship or attend a training course, and we can work through like the details of how the data functions and I can give advice. Or we do things, like I said, in a facilitating way where we're bringing people together. So we're involved in a lot of these big international organizations that aim to promote this kind of collaboration. So for example, we work with the International Ocean Color Coordinating Group. We work for the Group for High Resolution Sea Surface Temperature Measurements, the Ocean Surface Topography Science team. So these are all people who are experts from all over the world in these different topic areas. And we do things like we host meetings for them. We've just done one online for the GRIST group. And we can do things like provide funding for early career researchers to come to those meetings so they meet the relevant experts. So we try and do that so that we just try and connect the dots really to get the data and the experts from all over the world together. And those experts really do exist everywhere. I mean, we have very strong South African representation on most of those teams as well. I mean, GRIST and the IOCCG, for example, both have had very, very strong support from South African scientists working together with us in Europe, and we learn from each other that way. So yeah, that's kind of what we do.
Oh, that's really nice. Thank you so much.
You're welcome.
All right, thank you so much. I think that's all the questions.
Zandile, just before we go, I think we've lost
Dr. Hayley, a round of applause. And
Cynthia, we
sorry?
lost you there.
Yes?
We lost you for a little bit there.
Oh, sorry.
And
Probably the network. I just want
Cynthia, in the meantime, Zandile wanted to ask one last question, please.
Okay.
So Dr. Hayley, as we know that the next World War might be on because of water, is there any intensive research or intensive look into desalination, and how might that actually affect us in the near future?
Oh, that's a really good question. So I agree with you. I think water is one of our most precious resources. And I think, it's one that if there's anything that happens to it, it becomes a real challenge. I mean, you guys know this better than anybody if any of you are based in Cape Town after what happened with the drought situation. I mean, things like that happening on global scales are quite terrifying and I guess quite possible in our uncertain future with regards to climate change. Desalination is something that offers one way of managing it. How effective it is en masse globally, I mean, it still requires a lot of energy. So I guess we have to trade that off about how much energy can we use and where does that energy come from? Do we really want to put a whole load of coal power into desalinating water? Is it better for us to move to bring in different places to focus on efficiency? Yeah, I don't know. Not my specific area of expertise, unfortunately. There are some great people working on this at UCT, looking at like urban water management, of course, after I think, you know, the recent experiences in South Africa and Cape Town in particular. So I think desalination will definitely feature. Something I think we're going to need to look at, but it comes at a price, you know, has its disadvantages as well as being able to provide the water. So it'll be interesting to see what happens with it.
All right, thank you so much. I just want to thank you, Dr. Hayley, for your time.
You're welcome. It was lovely to speak to you all.
All right, let's just give Dr. Hayley a round of applause.
Thank you all for your great questions. It's always so nice to speak to people who have lots of questions. So I really appreciate that and really enjoyed it. Thank you.
Bye.
All right, thank you so much. And hopefully some of us will have an opportunity to work with you in the future.
I hope so. I'd love that.
All right, then. I think I'll then hand over to Dr. Carl.
Okay, thank you, Hayley.
Thanks, everybody. Bye-bye. Enjoy the rest of your course. Bye-bye.
Just very quickly before you all go, wow, that was fantastic. You guys, when asked to think of questions, you really stepped up. That's absolutely brilliant. Oh, let me...